And we've talked about loops when we were talking about pseudocode, and loops in Java are the same thing. They are used when you need to perform a process over and over, and the only thing that changes is the syntax when we write them. There are three types of loops that we're going to cover: the while, do while, and for. Here you can see the pseudocode for the while loop, and here's the Java syntax. The biggest thing to notice is that with Java, we add parentheses around our condition. And that's pretty much it. I want you to write some pseudocode for an algorithm that finds the sum of a bunch of user-entered integers using negative 999999 as a sentinel value. If you recall, a sentinel value is a value that you're unlikely to encounter during normal operations as a means to break out of the loop. So go ahead, pause the video, and think about and write down your algorithm in pseudocode now. You should have come up with something that looks like this. We have 0 going into the sum, and we're going to say, please enter an integer, and we're going to give them instructions on how to quit. The user inputs the value, and while x does not equal 99999, negative, we are going to add its value to the sum. And then it's going to prompt the user again to keep entering another value. And it's going to keep going back up to here and looping around and going back up and looping around until the user enters negative 99999. And once they do, the loop is going to exit, and then it's going to print the sum. Now, go ahead and code this up in Java. And you should have plenty of examples to use as a starting point if you're having difficulty getting started. So pause the video and come back when you're done. So hopefully your program looks something like this. If it's not exactly the same, that's okay. Did your program compile? Did it meet the requirements? There are many different ways to tackle this problem when programming. And often in class, we'll be looking at a particular method because we're studying it in class, but in the real world, as long as your program meets the user needs or requirements, then that's really all that matters. And there's a lot that goes into the user's needs and requirements, because there's functional requirements and non-functional requirements. Is it fast enough? So on and so forth. Does it take up too much memory? So there are a lot of different things to consider once you're actually programming it. But for now, don't get hung up on maybe the most elegant way of doing it. For now, I just want you to focus on, does it actually compile, and does it meet the intent of what you need it to do? Now, do loops are virtually identical to while loops with one caveat. The condition check is performed at the end of the loop rather than at the beginning. And this means that you're guaranteed to go through the loop code at least one time. And the syntax looks similar with one notable exception. See if you can spot the difference other than the obvious fact that the condition is at the end and it starts with the word do. Did you catch the semicolon at the end of the while? The compiler requires putting a semicolon at the very end after the do loop's condition. Also, proper style dictates that putting the while part on the same line as the ending brace. For practice, modify your code from the while loop to use the do loop instead. The for loop is something that we haven't quite covered yet. You use a for loop when you know exactly how many times you need to do the loop. You don't need to have the exact number, but when you write the code, the program needs to know by the time the loop is actually executed. For example, we could use a for loop to count down from 10. Or we could use it to calculate the factorial of a number. And for those who may not remember what a factorial is, the factorial of a non-negative integer n, denoted by n exclamation or n factorial, is the product of all positive integers less than or equal to n. For example, 4 factorial is equal to 1 times 2 times 3 times 4, which equals 24. And the value of 0 factorial is 1, according to convention for an empty product. So let's take a look at the syntax for the for loop. And you can see we have a starting initialization, a condition, and what to do at the end of the loop, or an update as it's known. So initialization, the condition, and update. And then inside of it, you have what's actually executed. So here's the code for the example on the previous slide of counting down from 10. You have for int I equals 10. Remember, that's an initialization. Some condition, so while I is greater than 0, subtract or decrement I. And so then we're going to print out I plus a space. Let's break it down step by step. The for loop semantic is such. Before the start of the first loop iteration, execute the initialization component. At the start of each loop iteration, evaluate the condition component. And if the condition is true, execute the body of the loop. And if the condition is false, exit the loop. At the end of each loop iteration, execute the update component and jump to the top of the loop. So we're going to update and then jump back to the top. And you're going to do that over and over and over. So again, initialize the counter. At the start of the loop, evaluate the loop condition. And if it's true, execute the body. It's covered by the green 2. And if it's false, exit the loop as indicative by the red 2. Perform the update function and go back to the top of the loop. Let's go ahead and trace some code so you can get some practice. Take a look at the following code, create a trace sheet, and assume that the input value is 3. As a side note, we often use the variable I inside of for loops, because I is short for index. We also declare a variable in the for loop heading, so we know that it is for the sole purpose of the index variable. So go ahead, trace the program, and I'll wait, but you should probably pause the video. And you should have gotten something like this, or something very close. Now, I've traced through the for loop using the criteria stated on a few slides back. So let's take a look at the loops and do a side-by-side comparison. With the for loop, if you know prior to the start of loop how many times you need to repeat the loop, then you'll want to go ahead and use it. And this is the syntax. For a do loop, you're going to do it if you always need to do the loop at least one time. And it looks like this. In the while loop, you're going to use a while loop if you can't use a for loop or a do loop. While loop is kind of like the general purpose. And there is the syntax for the while loop. So you can see it there. For, you're going to have initialization followed by the condition and an update. Do, you're going to just say do, and then you have your statements with a while and a condition ending in the semicolon, and the while with the condition with no semicolon. So that's critical that you remember those, and you'll get syntax errors if you screw it up. So there you have it. There's the 3 loops side by side, and you can know which one to use correctly. And a nested loop is just a loop inside of another loop. So think about how you would write a program that would print a rectangle of characters where the user gets to specify the height and width and the character used. Go ahead, pause the video if you'd like to write out the pseudocode or attempt to write a program. So here you can see our print rect class, and we have our main method, which you should be familiar with by now. Then we have a width variable, a height variable, a display variable, a string to record our quit, and then a scanner object so we can get user input. And you can see here I used a do loop because we're going to execute this at least once, and we're going to ask the user to input all of the stuff. Then basically what we're going to do is for however many rows or tall that this rectangle is going to be, we're going to execute the inner loop here, which is going to be based on the width. So it's going to go to the first row, and then it's going to print out however many characters that is specified in the width. And then it's going to go, and then once that's done, it's going to print an empty print line, which is going to force a carriage return, and then it's going to do it again. So it's just going to print row, print row, print row, print row, and then be done. So let's go ahead and compile this. We're going to continue evaluation, and we're going to run it. And so let's enter the width. So let's do 10. Oops, turn my numlock on, 10. And enter the height. Let's do 5. Enter a single character. How about ampersand? Enter. And there you go. You can see 10 ampersands across, 5 down. And would we like to do another? Sure. Let's do width. Let's do 35. And we'll do 8. And we'll do parentheses. There you go. It's that easy. Would you like to do another? No. We're going to use our no as our user input to abort our loop. And then that's done. The program's done.